So from today, I am going to start electromagnetic theory, and I welcome some new students, those who have joined from today. And this will be a very, very important topic as far as IIT JAM, CSIR NET are concerned. And I want to make it clear that for IIT JAM, we will discuss together electrostatics, magnetostatics, and electromagnetic waves. So up to this, the syllabus is same. And for CSIR net and JEST, TIFR, all that, we have to discuss little more. So I will tell the complete syllabus, and you should mark it कि IIT JAM के लिए कहाँ तक है, up to a point. And after that, if you are interested in JEST and TIFR also, then you have to cover the complete syllabus. Okay. So electromagnetic theory we have to discuss. Electromagnetic theory. In short, I will call it every time EMT. Okay. So the good thing about this is that this you have done little bit since your class 12th. Okay. And then in graduation, then in your post graduation, we have done this. So thoda sa there is little background. आप लोग के पास भी थोड़ा background है, so it will not be something which will be completely new. I mean, many times, many iterations you have done. So इसलिए, unlike some topics which you only discuss in graduation and post graduation, this starts from your class +2. Okay. So as a reference books, David J. Griffiths. Okay. So सबको इसका नाम भी पता ही है. So this is all time Griffiths. All time favorite books. Okay. So the name of this book is Introduction to Electrodynamics. So I have kept the books in the Google folder, Google Drive, and you can see it in your description. Okay. जो आपका WhatsApp group है, उसमें description में you can see the books are there. And soft copies are there to refer. This is one and the only book that you need. Okay. But another one also I refer for myself. So I must tell you, I always tell about all the references. So this Hayat is one of the books that is used by electrical engineers for their syllabus of electromagnetic theory, and a very nice book. Because there are two different approaches. I mean, things are same, laws are same, but a physicist approach and an engineer's approach. So this is for the engineers, so they prefer this book. And I take references from this also, क्योंकि कभी-कभी too much of physical interpretation के बजाय just straightforward what the calculation says, वो भी काफी अच्छा होता है, काफी interesting होता है, right? So these are the two books for the references, and we will develop a class notes while our discussion. So that will be ultimate. So you should have no confusion. And because there is no limitation of number of questions in electromagnetic theory. ढेर सारे क्वेश्चन जैम में आए हुए हैं, ढेर सारे क्वेश्चन गेट में हैं, नेट में हैं, जेस्ट में हैं, टीआईएफआर में हैं, जेएनयू में हैं. Okay, even Hyderabad Central University and DU also they have lot of questions on electromagnetic theory. So if you see as a whole, lot of questions are there to practice, and Griffith itself, Hayat itself consists of lot of questions. So आपको जिन चीजों पे ध्यान देना है वो कॉन्सेप्ट होंगे. क्वेश्चन करने को ढेर सारे आपको मिल जाएंगे. इवन आई टेक लॉट ऑफ क्वेश्चंस फ्रॉम, आई मस्ट टेल यू that I take for basic some basic problems. I take some questions from Irudov also. Okay, I take some questions from even JEE advanced questions, just some basic questions. But we have to actually go further than that. Okay, क्योंकि इसमें तो बहुत ही basic 12th level की चीजें हैं. But just for understanding, sometimes शुरुआत में it is required to make the base and feeling of electromagnetic theory. So वहां से भी मैं questions, I take questions from there also. Okay. So this was a little bit about how we will be and from where, what will be the references of the electromagnetic theory. And then comes the syllabus. So let us divide the broadly, let us divide the syllabus, what we are going to study. So I can put it into big brackets. बहुत छोटे छोटे divisions करने से जो है overall picture clear नहीं होती है. So there is a thin line कि आपको syllabus को कितना divide करना चाहिए. So already detailed syllabus are there. आपको पता है competitive exam में they are given. But you should broadly divide it as electrostatics, where the charge will be stationary, then magnetostatics, so this is charge stationary, this is current steady. Okay, so charge stationary is electrostatics, current steady is magnetostatics, and then so here that current will be independent of time, right? You have a steady current, constant value of current, and then you will have the current which is function of time. So then you will have the what is called, so we will discuss Maxwell's equations, in which you will have time dependent current, so time dependent magnetic field and electric field, creating magnetic field creating electric field. So all that we will discuss here. Then you have, so this is first section, broad sections I am making. This is second, magnetostatics. This is third. Maxwell's equation is actually, these two also are part of Maxwell's equation. But when I write it, I mean the Faraday's law and modified Ampere's law, where your current is not steady and your electric field is also function of time. Okay, let me write it here. So one is that del cross E is equal to minus del B by del T. You can see here B is constant. B is constant, not function of time. But here B is function of time. So if B is function of time, it will create electric field. And also del cross B, which is equal to mu naught J plus mu naught epsilon naught del E by del T. Del E by del T. Okay. So you can see here B depending on time. B is function of time. And here you can see E is function of time. So this is the third category where things are function of time. Then the fourth one is electromagnetic waves. The fourth section will be electromagnetic waves. So up to this is end of JAM syllabus. End of JAM syllabus. Okay. Then fifth one, we will discuss about the transformations. So let me put it all the rest one I will put it, let us say, in advanced electromagnetic theory. Okay, where we will discuss everything after. So it will be like potentials and fields, potentials and fields. That means your concept of retarded potential, concept of uh, uh, gauge transformation, all that, and also radiation, radiation, and little bit about where electromagnetic theory and special theory of relativity. So combined topic of that. So that will be discussed by uh, Atul sir at last. So after this, a small topic will come. I mean, small in terms of length, not in terms of its importance. Okay. So this is the outline of the syllabus. So किसी को कोई क्वेश्चन पूछना है? बिकॉज ये अंडरस्टैंडिंग बहुत जरूरी है. अगर आप एक बार पूरा आउटलाइन समझ जाते हो तो आप जैसे से यू स्टार्ट स्टडीइंग इट तो आप समझने लगते हो कि हाँ ये पार्ट मेरा हो गया, इसमें मुझे प्रॉब्लम आ रही है, ये पार्ट थोड़ा मुझे सही लग रहा है. इस तरीके से पूरा ओवरव्यू आपका बनना बहुत जरूरी है. सो एनीबडी वांट्स टू आस्क एनीथिंग? यस, फील फ्री टू. आवाज आ रही है ना मेरी?
Yes, sir.
हम्म. और एनी सजेशन? Is it okay? The flow of the topics? Okay. I think this is okay. Note कर लिया सबने? Can I erase this?
Yes, sir.
Okay.
Yes, sir.
Okay. Now, one very important thing I want to tell you about the vectors that will be used in electromagnetic theory. The vectors that will be used in electromagnetic theory. So that will be concept of dot product. Let me start from coordinate systems. Coordinate systems and dot and cross products, dot and cross products, some identities associated to them, concept of unit vectors. And when you read this coordinate systems, small, length, area, and volume, small length, small area. So how we write it? dl, dA, d tau, or sometimes we write it as dV, जो भी आपको पसंद हो. V is reserved for potential, so let us write it d tau. Okay. And two important theorems. One is three actually: Gauss divergence and Stokes and Green's. Okay. So these are few things that will be used in electromagnetic theory. Also, as things as small as triangle law, that is also used. So मेरा ये मानना है कि teaching these things separately may assist you as vectors for mathematical physics, some questions from mathematical physics. But as a concept, जब तक हम एक्चुअल ईएमटी में जहां पे वेक्टर यूज हो रहा है वहां पे जब तक हम जाके डिस्कशन नहीं करते हैं, फॉर एग्जाम्पल सपोज फॉर द केस ऑफ सम इलेक्ट्रिक फील्ड, व्हेन आई यूज ट्रायंगल लॉ, वो बिल्कुल सेपरेट फीलिंग है, वो बिल्कुल सेपरेट अंडरस्टैंडिंग है कि बजाय मैं जस्ट ऐसे ही पढ़ा दूं कि ए और बी वेक्टर्स को ऐड करने पे वेक्टर सी आ जाता है और ट्रायंगल लॉ ऐसा ऐसा होता है. सिमिलरली, like binomial expansion is used in calculation of potentials. So binomial theorem अलग से maths में बता देना कि 1 plus x to the power n का ये expansion है is a separate thing, but real feeling of that comes when you use it somewhere in between. So my idea is that while teaching electromagnetic theory, जहां जहां पे भी mathematical situations create होती हैं, even calculus, lot of calculus is used. So we should address it there itself. We should take time and discuss it there itself. वहां पे ही आपके उन queries का आंसर होना चाहिए कि why you are doing this, how you are doing this, in what situations we can use it again. All those things we can discuss. So my approach will be this. In spite of, instead of teaching everything separately as a topic of mathematics, it will be better if we discuss it in between electromagnetic theory. So every time we encounter a situation where something regarding vector use hua hai, regarding calculus use hua hai, regarding some cross product identity hai, some dot product identity hai, these things are used. So we should address it there itself. And uh, just leave first 2 pages or maybe 3 pages, just write the idea, the concepts or identities or formulas used in EMT, used in electromagnetic theory. Okay, just write it and then leave the 3 pages. Now I don't want to write all the identities immediately, whatever will be used. What we will use, what we will do is, I mean mathematical, all these are mathematical formulas, maths formulas. So जैसे जैसे हमें यूज पड़ेगा, काम पड़ेगा, वैसे वैसे हम वहां पे नोट करते जाएंगे. So every time we encounter a new thing, new concept, new formula, anywhere from this, we will put it on this page. So धीरे धीरे करके जैसे से तुम्हारी EMT प्रोग्रेस करती जाएगी, you will have all those formulas, collection of all those formulas which are already, which have been already used somewhere. Not as कि आप ऐसे ही पूरा कलेक्शन कहीं से उठा लो, उनमें से कुछ काम के हैं, कुछ काम के नहीं है. Not like that. From your experience, that with what we will discuss, वो सारी चीजें हम लोग वहां पे धीरे धीरे करके we will accumulating it. और वो that will be real wealth, real treasure, because वो already कहीं use हुए हैं, तो वो हमें पता होने चाहिए. उनको हम धीरे धीरे करके मार्क करते जाएंगे. Is it okay? ठीक है?
Yes, sir.
So is it okay how the about the approach? सबको clear है how we are going to do it?
Yes, sir.
Yes, sir.
और किसी किसी को कुछ पूछना है या इस अप्रोच में कोई किसी को कुछ, if anybody wants to ask anything? I think Everybody agrees with this? Okay. Yeah. Now let us start with electrostatics. Electrostatics. So I told you that electrostatics means our charge is stationary. Your charge is stationary means electrostatics. Okay. So ये पूरा कॉन्सेप्ट क्या है? कॉन्सेप्ट ये है कि you have a charge which can create certain effect. What effect it can create? It can put force on other charges, right? It can create a field around it. It can create a region around it in which other charge can feel a force. Then we will have the concept of potential difference. Potential difference. Potential difference will tell how much energy is needed to move a charge, because ultimately we understand everything in terms of energy. आप देखो कोई भी टॉपिक आप पढ़ते हो, ultimately you move to energy, because energy के terms में ही हमारी सारी physics चलती है. Like you read psi in quantum mechanics, but you end up calculating energies, because ultimate goal is that. So similarly here also we will come to potential difference, which will tell how much energy is needed to move a charge between the 2 points जिनके potential difference मैंने लिखे हैं. So finally we will reach to energy of the system. So this is how we go. So you know, Q we represent charge, F we represents force, E we represent electric field, V or phi both are very famous, so I am writing both. It is for potential difference and U is for energy. So these symbols I will be using. This is something very, very important, like a quantity like psi in quantum mechanics is inspired from E in electromagnetic theory. Let me tell you a very important thing. Electromagnetic theory inspires all the branches of physics, including quantum mechanics, including statistical mechanics. क्योंकि पूरा अरेंजमेंट जो है इलेक्ट्रोमैग्नेटिक थ्योरी में इतना प्रॉपर है, हर चीजें इतनी सिमेट्रिक हैं, सेल्फ एक्सप्लेनेटरी हैं, और जब भी कोई नई चीज डिस्कवर होती है तो वो उसमें बिल्कुल आसानी से फिट हो जाती है. लाइक you have classical electromagnetism, then you have quantum mechanics, and then when you apply quantum mechanics to electrodynamics, you have quantum electrodynamics. There is relativity, electrodynamics, and quantum mechanics. Then you have branch called relativistic electrodynamics, then relativistic quantum electrodynamics. So electromagnetic theory is kind of inspiration to all the branches, कि सभी लोग इसी से इंस्पायर होकर सारी चीजों को ऐसा ही करना चाहते हैं. वो बात अलग है कि हर ब्रांच में वो सक्सेस हमें नहीं मिल पाया है, बट स्टिल वी लुक फॉरवर्ड कि जैसे इसमें चीजें सिमेट्रिकली डिस्कवर होती चली गई, नई चीजें आई तो उसके साथ फिट हो गई, वैसे हर ब्रांच में हो जाए. ओके, सो दिस इज द सीक्वेंस. You have a charge, its effect is to create a force, and around a charge there is a region which creates a vector field. So you know concept of a vector field. Okay, so like simple vector is something like 2i cap plus 3j cap plus 4k cap, but vector field means it will be function of x y z. or r theta phi or rho phi z. So it describes the whole region around it. Okay, so that is, so electric field is not a vector, it is a vector field actually. Okay, which describes the whole region. Then you have scalar fields, because you want to make things easier. Vector always requires understanding of direction, so we switch to scalar quantities which can describe the whole system. So that's why we need concept of potential, and this is also a scalar. Energy is also a scalar quantity. So energy configurations are required to understand the system. So it goes like this. So इसी sequence में हम भी पढ़ते जाएंगे. We will understand the forces, then the fields, then potentials, then the energy configuration. Okay. So let us start with the force. So topic that will be going on will be electrostatics. So just put it as units, like first is this, then second is magneto, and like that. Okay. Electrostatics. About stationary charges. Stationary charges. So suppose you have two stationary charges like this. This is Q1, this is Q2, and this is some coordinate system. So let this be a coordinate axis x, y, z, which you have read in your high school mathematics. Okay, this is origin, and let Q1 be at some r1 distance. This is vector called position vector, and Q2 be at some r2 distance. So this is also a position vector of Q2. And let this distance is some capital R, like this. And it is from R1 to R2, like this. Okay. So what I am going to discuss is known as Coulomb's law. Coulomb's law. Okay. So Coulomb's law tells about the forces between the two charges. It is proportional to Q1, Q2. Okay. Just the magnitude. And it is inversely proportional to the distance between them. So it is 1 over, I can put small r also, not capital R is not required. So let me put it a small r as 1 to, from 1 to 2. So it is inversely proportional to r square. This is Coulomb's law. So when you combine it, it becomes like this. F, force on 1 I am writing first of all, force on 1 due to 2. Please see this carefully. It is equal to 1 upon 4 pi epsilon naught Q1, Q2 over R12 square. So this has no vector at all, but if both are positive, that means if Q1, Q2 multiplication is greater than 0, then they will repel. And if Q1, Q2 is less than 0, then they will attract. ठीक है? So यहाँ पे तुम देखोगे कि this will be repelled from this. So just extend this line. They will just run on the lines. So it will be repelled. So repelled means it will be in the direction minus R12 cap. And this is called unit vector. This is called a unit vector. Unit vector means vector itself divided by its magnitude. I promised you to give every detail. So whatever I will be using, I will be putting it right there. So this is the role of unit vector. You just want this direction. So you have written R12. And if you write force on 2 due to 1, so everything is same. It will be 1 upon 4 pi epsilon naught Q1 Q2 over R12 square, or you can write 21 square, nothing will change. Because the distance R12 and distance R21 is same. And this will be R12 cap because it will run in this direction, in the direction of R12. This will run in this direction. Okay, minus R12. So that's why they will feel equal and opposite force of 12 is equal to F21. And this, what I have wrote, is the Coulomb's law. So this was the first law which can tell about the forces between the two charges. And this appeared as a constant. So in SI unit, 1 upon 4 pi epsilon naught is 9 into 10 to the power 9. And because I am writing this, it is Newton meter square per Coulomb square. So it is Newton meter square per Coulomb square. Okay. And the value of epsilon naught alone, which is the property of the medium, electric property of the medium, it is permittivity of free space, of free space, permittivity of free space. The value is 8.85. सही लिख रहा हूं? किसी को याद है?
10 raised to minus 11.
8.85 into 10 raised to the power minus
11, sir, I think.
11.
sir.
No, sir, 12, sir.
Sir, 12.
Sorry. I think that is okay, na?
Yes, sir.
Okay. So this is the basics of Coulomb's law. That if there are two charges, then you can write force between them. तो यहां तक सबको क्लियर है सब कुछ? देखो बिल्कुल आराम से पूछते जाओ, फटाफट अगर कोई डाउट भी है तो वो हम क्लियर करते चलेंगे, चाहे छोटी चीज है चाहे बड़ी चीज है, कोई दिक्कत नहीं।
सर ये यूनिट वेक्टर को माइनस एक और प्लस किसी वजह से समझ नहीं आया।
सोचो जरा, सोचो, मैं साथ साथ आपके ऊपर भी प्रेशर डालता रहूंगा। तो पहले सबसे पहले आपने किस पे फोर्स निकाला है?
1 से 2 की ओर से।
1 से
R1
2
से
की
R2।
ओर नहीं, फोर्स ऑन 1, पहले इसको पढ़ना सीखो। फोर्स ऑन 1 ड्यू टू 2, व्हाट इज दिस? मैंने क्या बोला है? फोर्स
1 ड्यू टू 2।
फोर्स ऑन 1 ड्यू टू 2। 1 पे फोर्स 2 के वजह से, तो ये किधर जाएगा? R12 के डायरेक्शन में जाएगा या इसके अपोजिट?
R12 की डायरेक्शन।
ये इधर जा रहा है, तो ये R12 के डायरेक्शन में जा रहा है। बोलो राजकुमार।
इसे समझ में नहीं आया।
समझ में समझो ना, तब तो समझ में आएगा। R12 वेक्टर किधर बना हुआ है? इधर बना हुआ है।
यस सर।
और मैं ये कह रहा हूं ये इधर जाएगा, और आप कह रहे हो कि ये इसके तरफ जा रहा है, तो इसको कैसे समझाऊं मैं, बताओ?
रिपेल हो रहा है सर।
ये इस तरफ है वेक्टर और ये इस तरफ है, तो दोनों एक ही डायरेक्शन में है।
अपोजिट डायरेक्शन।
तो अपोजिट है, तो इसीलिए तो माइनस साइन लगा लिया है,
यस।
क्योंकि R12 वेक्टर से इसकी डायरेक्शन अपोजिट है। और जब मैं इसको लिख रहा हूं फोर्स ऑन 2 ड्यू टू 1, तो ये इस तरफ जा रहा है। तो बिकॉज ये R12 के ही डायरेक्शन में जा रहा है, इसलिए इसको R12 ही लिख लिया है। ओके।
ओके सर।
और किसी को कुछ पूछना है? सिंपल ये लॉजिक लगाना है सबको कि अगर दोनों चार्जेस पॉजिटिव हैं या दोनों नेगेटिव हैं तो रिपेल करेंगे। तो इसीलिए मैंने लिख दिया Q1 इंटू Q2 इज ग्रेटर देन 0। तो अगर दोनों प्लस प्लस हैं तो भी ग्रेटर देन 0 होगा, दोनों माइनस माइनस हैं तो भी ग्रेटर देन 0। अगर एक प्लस एक माइनस है तो भी लेस देन 0 है, और अगर एक माइनस एक प्लस है तो भी लेस देन 0। ओके। ठीक है, चलो। कैन आई इरेज दिस?
यस सर।
So the Coulomb force also follows superposition principle. Superposition principle. Coulomb force superposition principle भी follow करता है. So that means मान लो if there is one charge, suppose that is Q naught, and there are so many other charges Q1, Q2, Q3, dash 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 Qn. So net force on Q naught will be equal to force due to Q1 plus force due to Q2 plus force due to Q3 plus dash 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 force due to Qn. So that means this superposition principle, force on Q naught is equal to summation I1 to N and F QI. So this is the superposition principle, right? So ये बड़ी अच्छी बात है कि दे फॉलो सुपरपोजिशन प्रिंसिपल। तो एक बार में वी हैव टू अप्लाई ओनली कूलम्स लॉ कैन बी अप्लाइड ओनली बिटवीन टू चार्जेस। सो जब आप इसको और इसको फोर्स कैलकुलेट कर रहे हो तो आपको बाकी चार्जेस को ध्यान देने की जरूरत नहीं है। एक बार में दो दो चार्जेस लेके टोटल फोर्स निकाल लो, उसको वेक्टर सम कर लो, दिस इज वेक्टर सम। सो अगर आप वेक्टर सम कर लेते हो so that will be your net force. So that means the Coulomb force, it follows superposition principle. Okay, superposition principle को follow करता है। तो let us solve some problems on this, and force के साथ ही पहले मैं field का भी concept बता देता हूँ, and then we will solve some problems on it. Okay. So suppose we take So because the Coulomb force can be applied between 2 point charges. So this does not tell about the properties of system of charges. Okay? क्योंकि हमेशा आपको दो चीज के बीच में फोर्स निकाल सकते हो आप, किसी चार्ज की या चार्ज सिस्टम की प्रॉपर्टी बताने के लिए यू हैव इलेक्ट्रिक फील्ड. So this is more better concept because it is the property of a charge or charge system, and we write electric field as force per unit charge. This is the field. So like suppose force between two charges was 1/4 pi epsilon naught q naught by r square, let the direction was some r cap, then it is divided by q naught, and this becomes 1/4 pi epsilon naught q by r square and r cap. So this is the electric field. So electric field is just the property of a single charge like this. If you want to calculate the electric field at this point P, and suppose this charge is at the origin, then this will become R, vector R, and at this point electric field is given by 1/4 pi epsilon naught q by r square in r cap direction. No other thing is required. So इस पॉजिटिव चार्ज की वजह से यहाँ पे फील्ड जो होगी उसकी डायरेक्शन होगी put a positive charge here, put a positive test charge here. वो जिस डायरेक्शन में जाएगा that will be the direction of electric field. So suppose you have a positive charge, so you put a positive charge anywhere, it will go like this. So that's why the electric field is like this. This is the direction of electric field for positive charge. And if you take a negative charge, here, and for test charge you will put a positive charge, it will come towards this like this. So that's why the field direction will be like this. ये बहुत important है समझना, because in the questions हम फटाफट field की direction बना लेते हैं. So this is when your q charge is greater than 0. This is when your q charge is less than 0. So if you put a positive test charge here, it will go away. That is the direction of field. And if you put a positive test charge here, it comes here. So that is the direction of field. So field lines are drawn. That tells about the electric field in the region. So field किसकी property है? This is property of the region. This is not property of a point, please understand. This is property of the region around that charge. And that's why this is a vector field. This is not a vector. This is a vector field because it is the property of the region. F-I-E-L-D. This is vector field. This property of the region around a given charge. So these field lines, if they are dense, that means closely spaced, they represent very, very high electric field. If they are rare, that means the value of electric field is, the magnitude of electric field is very low. Due to same source, they never cross. Due to same source, they never cross. They never cross. These field lines never cross. They don't have sudden breaks. So no sudden breaks. This is all you have done in your class 12th. but I have to start from the beginning. That's why I'm taking it from you from there. So ऐसा नहीं होगा कि फील्ड लाइंस ऐसे आ रही हैं और ऐसे ब्रेक हो जाए, क्योंकि अगर ऐसा है तो इसका मतलब यहाँ फील्ड 0 है और उसके नेबरहुड में फाइनाइट है, तो ऐसी डिसकंटिन्यूटी फील्ड में नहीं होती है. ओके, so field lines will not be like this. From the same source you will not find the lines crossing each other. From different source they can cross, but from the same source they will not be crossing each other. Okay, so these are the properties of the electric field also. And यहाँ तक clear है? I have to erase this to discuss the next thing. यहाँ तक कोई प्रॉब्लम है वो भी पूछ लो. क्लियर है भाई?
Yes, sir.
Okay, is it clear?
Yes, sir.
Okay, so the concept of field हम लोग बहुत लास्ट तक भी पढ़ते रहेंगे, because I told you like psi is so important in quantum mechanics. From psi you can get everything, so that's why in the same way field is very important. Electric field and magnetic field, they work like a state function. They can tell you everything about the system. Okay, so what we have read is that if you have some charge, let me write it as dq, and you want to calculate electric field in this region, which is at distance r. Let us forget about the direction for a small amount of time. So dE is given by 1 by 4 pi epsilon naught dq by r square. This is the formula that we have done. ये देखो समझ आता है? Small electric field. So from here calculus I am introducing, because many times we will have to calculate small electric field and then we will have to integrate it. Okay, अब ये जो छोटा सा चार्ज है, this small charge can be on a small length, then we will write it like this. Can be on a small area, then we can write it like this. Can be on a small volume, then we can write it like this. तो चार्ज अगर लेंथ में है, small charge, this is small charge dq, so this length is dl. यहाँ पे चार्ज dq हो सकता है, that will be given by lambda dl, because lambda is the charge density, charge per unit length, charge per unit length. If it is like this, some area, and you consider a small area, this is dA, then charge can be like this, dq, it will be given by sigma dA. And if you have some volume, some three-dimensional, and this is a small volume, say d tau, and here the charge density is sigma, this is charge per unit area, this is charge per unit volume, then dq is given by rho d tau. So this is 1d, this is 2d, and this is 3d, because this will be spread on the line, this will be spread on the area, and this will be spread in the volume. So lambda क्या है? Charge
Line charge.
by length. Sigma क्या है? Charge by area. Rho क्या है? Rho is charge by volume. Charge by length, charge by area, and charge by volume. So this I will be using for electric field to write the small electric field due to small charge, and a small charge seeing what type of the system is there. System is very important to understand in whole of the electrodynamics. System 1D है, 2D है या 3D है. Depending on that, you will write lambda dl, sigma dA and rho d tau. This you have to understand. Right? समझ आ रहा है भाई सबको? So if you want to write small electric field at this point, then you have to follow this, right? 1/4 pi epsilon naught dq by r square, and then if it is 1D, write lambda dl. If it is 2D, write sigma dA. If it is 3D, write rho d tau, and accordingly take the values and then integrate it to calculate the complete. So what will be electric field actually? It will be integral dE. ये पूरा प्रोसीजर होगा कैलकुलस का. ध्यान से देख लो सभी लोग. I will be using it again and again. Yes? तो शुरू में जब आप पॉइंट चार्जेस लोगे, पॉइंट चार्जेस, then no problem. Total electric field will be just summation of electric fields due to different charges, right? But जब you will take continuous charges, continuous means spread on length, area or volume, then you will write E is equal to integral dE. Is this clear? देखो जरा सबको बात समझ आती है?
Yes, sir.
Okay, so now थोड़ा बहुत कॉन्सेप्ट अब डिस्कस हो गया है, इतना कि हम कुछ क्वेश्चंस लगा सकें. So let us try to solve some questions. So this question is, suppose we have very simple. I am starting it the whole thing with a very simple question, and then slowly and slowly we will discuss better and better questions. So first question is like this: we have plus Q and plus Q, two charges. Okay, we have put it like this, and just find the electrically neutral point, what we call as electrically neutral point. Find out the electrically neutral point. So that means where the net electric field is 0. So suppose this distance is d, and let us take a point O. समझाने के लिए है, ऐसे तो पता ही है. This distance is x, so this will become d minus x. ध्यान से देखना. So let's take this point O here. This is O. So because of plus Q charge, there will be a field like this side, because of plus Q charge, because of positive charge will be outside the point. You remember this? Plus Q charge, this is the point, suppose P, so field will be this side. And because of this charge here, field will be on this side. पहले तो ये चीज समझो, ये बहुत जगह यूज होने वाला है. देखो सबको समझ आ रहा है?
स्टार्स का साइन पॉजिटिव ही होगा।
सॉरी, प्लस
नहीं,
व्हाट?
यस सर,
आवाज ब्रेक हो रही है आपकी क्या?
यस सर, यही बोला था सर, माइनस
अच्छा,
लिख दिया था आपने।
हाँ हाँ, ठीक है। Radhika, is it okay?
Yes, sir.
So now what is the net field? So you write this one first of all. It is 1 upon 4 pi epsilon naught. So if you take this as a vector, let us take this as a vector, unit vector. Let us take x cap. X cap is unit vector in this direction. Okay. So it will become q by x square x cap plus net field is, I told you, by superposition principle, it is sum of the fields there. So this and plus this. So that will be 1 upon 4 pi epsilon naught q by d minus x whole square and minus x cap. Rajkumar ji, देखिए आप समझ पाए? And this should be 0 according to the requirement of the question. So 1 by x square will become 1 by d minus x square. So d minus x will become x. So x will become d by 2. So that means at the center, we will have electrically neutral point. So first part was to get the electrically neutral point. Is it okay? सबको समझ आ गया? क्या हुआ भाई, एकदम ही आप लोग?
Yes, sir.
When I ask, at least few of you should answer, okay? तो सबका थोड़ा सा क्लास में मोटिवेशन भी बना रहेगा. Is it okay? Got it?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Now इसमें डायरेक्शन वगैरह लेने में किसी को कोई दिक्कत नहीं, क्योंकि ये देखो मैं सिंपल प्रॉब्लम से शुरू कर रहा हूं. बट ऐसा नहीं है कि दिस इज द स्टार्टिंग, दिस विल नॉट बी द एंड. ओके, वी विल टेक ऑल टाइप ऑफ प्रॉब्लम्स इन द ड्यू कोर्स. बट कॉन्सेप्ट्स, जो बेसिक कॉन्सेप्ट्स हैं, डायरेक्शन वगैरह लिखना, ये क्लियर है? मैं पहले राजकुमार जी ने पूछा था, अब देखो जरा, क्लियर है राजकुमार आपको?
yes, sir.
ये डायरेक्शन मैंने माइनस कैसे किया, समझ आ गया ना?
Yes, sir.
ओके. तो इसका मतलब जो ये पॉइंट है, दिस इज इलेक्ट्रिकली न्यूट्रल पॉइंट, राइट? अब बी इज, इसी क्वेश्चन का पार्ट बी है. पार्ट बी इज पुट q charge at O. What is force on q charge? बताओ भाई. यहां पे q चार्ज रख दिया आप इलेक्ट्रिकली न्यूट्रल पॉइंट पे, तो उस पे फोर्स कितना लगेगा? फोर्स होगा q इंटू इलेक्ट्रिक फील्ड. आपने निकाला ना?
Zero.
इलेक्ट्रिक फील्ड इज फोर्स पर यूनिट, so that will be 0. This is part B. Is it okay? Part C, displace q little bit. What will happen? What will happen? थोड़ा सा डिस्प्लेस करते हैं q को, then what will happen? So please see this. If you displace q little bit from this position, then the question is what will happen? So if you displace q little bit, suppose this is at D, this is at D, okay? Let us displace this towards right. So जैसे ही ये it will come towards the right, ये वाला charge ज़्यादा force लगाएगा उसके ऊपर and it will push it towards the left, और जैसे ही left जाएगा ये वाला force ज़्यादा लगाएगा. ज़्यादा, why more? Because force is inversely proportional to the distance. जैसे ही distance reduce होगी, force will increase. So it will start oscillating. क्या होगा? It will start oscillating. And now the question arises, what is the frequency of that oscillation? So what is now your situation? You have charge Q, this is O, you have displaced it here. So now Q charge is here, and this is again charge Q. Now this is D. This is D. So what is the force felt by charge Q? Please see this. Make a free body diagram. So this is pushing it towards, so this will be pushing it towards this direction. This, what is this distance? D minus X? Yes or no? So 1 upon 4 pi epsilon naught QQ by D minus X whole square minus 1 upon 4 pi epsilon naught. I am calculating the net force, okay? So net force is, this force is greater, so I am putting it here, QQ by how much? D plus
X plus D.
D plus X का whole square. This is your net force. Net force. ये देखना समझ आ रहा है? So this will be QQ over 4 pi epsilon naught D plus X whole square minus D minus X whole square upon D square minus X square whole square. This is net force by Newton's law. Force is M into A. So I am writing it as M into A, acceleration. So calculate it quickly. So it will be QQ by 4 pi epsilon naught and D square plus X square plus 2dx and minus D square minus X square plus 2dx and upon. So please see, if X is very, very small in comparison to D, I can write D square minus X square as D square. So it will be D to the power 4. So this will cancel and it will become M d2x by dt2. So restoring force is opposite to x, na? Yes? So how, what it will become? Batao. It will become minus of कितना आ रहा है? 2dx. 2dx upon 4dx 4dx upon d cube into q by 4 pi epsilon naught. एक बार चेक कर लेना जरा. Is it okay? So to write it finally, it will become d2x by dt2
minus
because this is acceleration and this is displacement. Both are vectors, both are having opposite direction. मैंने ये यहाँ पे एफ नेट देखो किसको लिख दिया, ज्यादा वाले फोर्स माइनस कम वाले फोर्स पे, राइट? और ज्यादा वाला फोर्स किस साइड था? इस साइड. यस और नो? हेलो.
yes, sir.
So if this is the acceleration, the displacement is this side. So both are in opposite direction, right? If you write it as a vector equation, दोनों की direction opposite है. So d2x by dt2 will become this plus sorry
डी कैंसिल होता है.
d cancel कर चुका हूं मैं already, right? तभी तो d cube लिख दिया था. So it will become 4.
4 भी कैंसिल.
नहीं 4 नहीं कैंसिल करते हैं. Okay, 4q upon d cube 4 pi epsilon naught. कहीं आंसर में लिखना हो तो कर देना, अदरवाइज 4 pi epsilon naught वैसे ही रहने देते हैं, राइट? बताओ क्यों?
9 into 10 raised to 9 is
हाँ, ताकि उसको हम यूज कर सकें कभी जरूरत पड़ने पे. इंटू m यहाँ आएगा, दिस इज 0. ये किसकी इक्वेशन है? सब लोग ध्यान से देखो. सिंपल हार्मोनिक ऑसिलेटर. कैसी होती है इक्वेशन? d2x by dt2 प्लस ओमेगा नॉट स्क्वायर या ओमेगा स्क्वायर x इज इक्वल टू 0. कंपेयर कर लो, ये भी बहुत जगह यूज होगा. सिंपल हार्मोनिक ऑसिलेटर इक्वेशन. सो ओमेगा स्क्वायर कंपेयर कर लो, so it will become qq by dq pi epsilon naught m. आंसर लिखने के लिए 4 हटा रहा हूं. ओके, so omega will be under root of this. This is the frequency with which it will be oscillating. So इसको ध्यान से देख लेना. x और acceleration, इस साइड acceleration है, इस साइड displacement है. So if I displace it in this direction, positive x, acceleration is in this direction. If I displace it in this direction, then acceleration is in. So acceleration and displacement are always opposite. So that's why this negative sign. Is it okay? Tell me.
फोर्स सर दोनों तरफ से इक्वल लग रहा होगा सर.
Sorry?
फोर्स सर इक्वल लग रहा होगा दोनों तरफ से ऑसिलेटिंग में सर.
मैं समझा नहीं आपका क्वेश्चन क्या है.
फोर्स सर जो फोर्स लग रहा होगा सर इलेक्ट्रिक फोर्स सर दोनों तरफ से इक्वल लग रहा होगा सर ऑसिलेटिंग टाइम सर.
जब तुमने इस तरफ डिस्प्लेस किया,
यस सर.
तो देखो ध्यान से, यहां पे सेंटर पॉइंट है, यहां फोर्स 0 है. इस पॉइंट का नाम मैं 1 रख देता हूं, इस पॉइंट का 2 आपको समझाने के लिए. अब बताओ क्या क्वेश्चन है?
सर पॉइंट 1 और पॉइंट 2 से जब
पॉइंट 1 पे आएगा तो फोर्स इधर लगेगा.
यस सर.
और जब
फोर्स
पॉइंट 2 पे आएगा तो फोर्स इधर लगेगा.
फोर्स दोनों इक्वल होगा सर.
वो तो उस पे डिपेंड करेगा कि एक्स कहां पे हो.
ओके सर तो पहले से दिया हुआ है.
फॉर ये देखो ना, जो तुमने सब्सट्रैक्ट करके लिखा है, एफ नेट देखो क्या है,
यस सर देख.
उसमें एक्स आ रहा है या नहीं आ रहा है?
यस सर.
तो उस पे डिपेंड करेगा ना.
ओके सर.
हाँ, अगर तुम यहाँ पे सपोज 1 सेंटीमीटर पे हो और यहाँ भी 1 सेंटीमीटर पे हो, तो दोनों फोर्स इक्वल होंगे। ओके,
यस सर।
बट ऐसा नहीं हो सकता कि यहाँ पे यहाँ वाले फोर्स को तुम इससे कंपेयर करो। ओके, एनी अदर थिंग एनीबॉडी वांट्स टू आस्क?
सर
हाँ,
सर अगर चार्जेस अपोजिट होंगे तो ऑसिलेटरी मोशन नहीं होगा ना?
अब जो आप क्वेश्चन पूछो उसको खुद सोच के देखो। ये प्लस क्यू है, ये माइनस क्यू है, ये सेंटर है ओ। आप क्या रखना चाह रहे हो? माइनस क्यू चार्ज। ओके, हेलो,
यस
ये वाला इसको धक्का मारेगा इधर,
यस
ये वाला इसको अट्रैक्ट भी इधर ही करेगा,
यस सर।
तो ये भाग जाएगा इधर इसकी तरफ।
ओके सर।
So that will not be oscillatory. Oscillatory system will be formed if force is proportional to minus of displacement. Okay, that is the concept of simple harmonic oscillator, right? जैसे इस केस में बना, that force was proportional to, यहाँ पे देखो, force was proportional to negative of displacement, then only your oscillatory system will be formed. इस simple harmonic oscillation होगा with some frequency, and this is only when small oscillation you are giving, otherwise you can't make that approximation जो मैंने किया है. What was that approximation? D square minus x square, roughly I took D square because D was much greater than x. So this is the approximation that I have applied. Okay,
ओके सर।
so this was for your first class. So please अच्छे से रिवाइज करते रहना डेली का डेली. If you sit for a small amount of time also, you can revise what I have discussed. अगर आप रिवाइज करते रहोगे तो नेक्स्ट क्लास और बिल्डअप होगी, तो वो प्रॉब्लम आपको नहीं आएगी. ओके, ठीक है, थैंक यू सो मच.
थैंक यू सर।
Yes, sir.
Thank you, sir.